Hello engineers, welcome back to Engineering Design Simplified. If you want to learn more about how to analyze mechanisms using analytical method, please subscribe to my channel and press that bell button so that you will be notified when I upload a new video. In this video, I am going to discuss slider crank mechanism static force analysis. So in this problem, for the angular position theta equal to 60 degrees of the crank, the gas pressure on the piston induces a compressive force P in the connecting rod along its center line. If this force produces a moment of 720 Newton meter about the crank axis O, calculate P. In this problem, given is a vertical slider crank mechanism. So this link OA is crank and angle between vertical line and crank is theta. So length of this crank is 125 millimeter and this link AB is coupler and its length is 300 millimeter. So there is a gas pressure is applied on the piston. So this pressure will produce a force P along this center line of this link, coupler link AB. So this force P will induce a moment of 720 Newton meter about this O on this crank. So in this problem we need to find the P required to produce this 720 Newton meter. So first we will derive an expression between this force P and moment and later solve the problem. Now let us see the geometry. So angle between crank OA and this vertical line here is theta, that is given. So let us call this angle here, angle between this vertical line and this coupler is alpha. So let us call the coupler link length is L3 and crank length OA is equal to L2. So let us draw a line from A onto this vertical line, a perpendicular line. Let us call this point A prime. So now we have two triangles, A prime, B, and another triangle A prime, O. So from these two triangles, this distance A prime can be written as from this first triangle A prime, O. So this distance A prime can be written as, since this length is L2 and this angle is theta, so that is L2 sine theta. Now from this triangle A prime B, let us write A prime equal to L3 into sine alpha. So that is written here. So L2 sine theta equal to L3 sine alpha. So from this expression we can write alpha equal to sine inverse L2 by L3 into sine theta. In the problem given that there is a gas pressure on this piston that produces a force P along this link AB. So that is drawn here. P is acting along this. So angle between this vertical and P is alpha. Now this angle is theta. So if this angle is theta, now let us draw a vertical line here. So then angle between this line and this line will also be theta. So this angle is alpha. So angle between this line and this line will also be alpha. So from this geometry we can write angle between these two lines is theta minus alpha. So then this distance, the perpendicular distance from O onto this link AB, can be written as L2, since this length is L2 and this angle is theta minus alpha. So this distance is L2 sine theta minus alpha. Now this force P produces a moment about O on this crank OA. So that moment can be written as T equal to this P into this perpendicular distance. So that is written here, T equal to P into L2 sine theta minus alpha. So from this expression we can write P equal to T by L2 sine theta minus alpha. So we are going to use this expression and the expression for alpha we have seen in the previous slide to solve the problem. Now let us see the problem. So theta equal to 60 degrees, T equal to 720 Newton meter, L2 is 125 millimeter, L3 is 300 millimeter. So from these values, the expression to find this angle alpha we have seen previously, alpha equal to sine inverse L2 by L3 into sine theta. So using this expression we can find alpha, this angle alpha, as 21.15 degrees. Now using this expression P equal to T by L2 sine theta minus alpha, let us substitute all the values and simplify. So we get P the force due to the gas pressure on this piston, the force P along this coupler link, P equal to 9182.5 Newton. So this is the answer. That's all for today's video. If you like this content, please like, share and subscribe. Thanks for watching.